It looks like it's working. All right, cool. And as Alex said, I'm Tyler Leonhardt, and I'm going to be presenting on conditional types. And there's some links to this presentation. I'll give you a second. I don't see anybody entering them in though, so I'm just going to go on. They're for the YouTube people. I'm going to be covering conditional types. Then I'm going to talk about infer, which builds on conditional types. I'm going to use two simple, contrived examples to describe those. And then I'm going to use a real example. And then I'll do a live demo of software that uses that example. And then I'll take questions at the end. One last thing, there's something called distributive conditional types. I will not be covering those in this talk. All right, let's get started with conditional types. A conditional type is really similar to the ternary operator. So if you've ever used this question mark operator in JavaScript, it lets you put a condition, and then after the question mark, you'll have two results, the true result and the false result. And a conditional type just lets you do that with types. So if this condition here, if hello world does in fact extend string, which it does, the result will be number, and otherwise the result would be string. And we use that below. We said this number assigned is a hello conditional. This entire thing resolves to number. So you can almost copy this and paste it right here. So we're able to assign 0 to it. On the other hand, if we tried to assign a string, we'd get an error. And I just want to point out really quickly, this sort of caret thing right here, I'll be using that to underline throughout my talk. Generics can also be used inside of conditional types. So I'm going to go back and forth here just so you could see no generic, and then we could add a type parameter right there. This lets you test the type parameter for various things and change your type depending on the type of the type parameter. This specific example will convert strings to numbers, and it'll leave all the other types the same. If our t comes in and it is a string, the result will be a number. You can see that in the first example, we pass in a string and we get assigned 0. In the second example, we pass in a specific string, the string hello world. Again, we get assigned 0. But a Boolean is not a string, so it resolves to t. Since the t we passed in is a Boolean, we can assign true to it. If we switch the order in this conditional type, this one specifically, it'll become more constrained. This is kind of interesting. And I'm curious, does anybody know which examples will break after I swap that? Example 1, 2, and 3. Anybody want to guess? A useful way to think about this is to interpret extends as is more specific or equal to. So we could say, is a string more specific or equal to the specific string hello world? It's not. The specific string hello world is more specific, and therefore it's our second example which breaks. You could use that. This is, again, a contrived example, but you can use that with other types to add additional checks throughout your code. All right, so that's it for conditional types. We'll build on that with another feature called Infer, which was released at the same time, I believe. So our infer in this example is right here. It lets you extract a type from a type parameter, which is generic. So this type parameter, t car parts, extends this generic I car parts interface. And we say we don't know what's inside of it, but there's some sort of car part inside of it. And we could copy and paste that bit and say t car parts extends I car parts, and then we could use this infer keyword to get the actual type parameter out of our I car parts. You use the conditional type syntax, and then you put whatever you inferred as the first thing after the question mark. In this case, we've got a car, we pass in this I car parts with this gas engine. The result is going to be the gas engine. Since that has a fill up method on it, we're able to call fill up on this car. One thing I'd like to mention here is it seems kind of dumb that you'd have to duplicate this extends clause right here. it is actually somewhat frustrating, and it would seem to be the case that infer would be more useful if you didn't have to do that. Currently, TypeScript only lets you infer types in the extends clause of a conditional type, so you can literally only do it right before the question mark and right after extends. It's kind of frustrating because it does create this sort of duplication where we have to say extend icar parts twice, but it is currently the only way of using infer. And again, it can only be used if you see those three things. Also released with these features was this never keyword. So let's go into what that is. Never just lets you create types that you can't assign to. It's useful for creating invalid cases. So if we took a 0 and cast it to any, you can't assign it. Even though you could supposedly assign any to anything, it will not let you assign it to never. If any is a member, it also can't be assigned to a never that's a member. And then another feature of never, if it's used in a union, it will be removed from the union. So if we have item, this is an intersection, sorry, if it's used in an intersection, it will be removed from the intersection. So if you have item or never, this will resolve to just item. There are many built-in types that use infer. Two of the most common ones are parameters and return type, and they let you extract information from functions. They're really useful. So parameters lets you extract the parameter of a function. You'd say t extends some function with some parameters, and then you can infer the parameters and return them in the conditional type. And likewise, with the return type, you can say this function returns something. You can infer the thing that it returns, and you can use that as a result of your conditional type. Parameters get returned in arrays. So this function right here has a number as its first parameter. The result of this whole parameters type would be an array with one element, which is a number. If this were a number and a string, it would be an array with two elements, the first one being a number and the second one being a string, and so on as you add parameters. And then the return type is a little bit more obvious. It's just whatever the return type was. So this thing at the bottom resolves into a string. We can assign hello to it. There's a bunch more built-in conditional types in node modules, TypeScript lib.es5.e.ts. So if you ever went in this file, you could find a bunch of really useful ones. They're kind of neat to look at if you ever want to see how some of these things are constructed. This is where I went to pull the definition for parameters and return type. And one last thing I'll say about that is actually the primary way you'll use conditional types is through other types that are already using them. They're actually pretty rare to use on their own. But we'll go and do an example where we do use one. So for our example, we're going to be building an error library. We're going to have this new error function. It's going to take a string, I'll call that a tag, as the first parameter. And then it will take an object that has a bunch of functions. So a map with string function pairs. And then we're going to be able to define a type for this thing right here. This type is going to be a union of all the return values. And I'll get into what this is doing. This is going to take these return values right here. So we're going to define a bunch of different errors we might have. With loading files, you might have some issue with the file not existing, or you might have some issue with you tried to load the file, it did exist, and you don't have enough memory. And it'd be good to have the file name, so that's good. And then for the other error, we want to have the object size. But by putting it through this new error function, we're going to bolt on additional data. So we're going to bolt on this load error tag. And then we're also going to bolt on what I'll call the subtype, this string right here for this error, or this not enough memory error string for this second error. And then at the bottom, I kind of show how that can be used. I'll stop using the pointer so that this thing goes away. We can call, on the second to last line, we could call the file load error function, and it's going to return a load error. This might be deeply nested in a call stack. If it's loading a file, the function might return a string or some sort of loading error. And then once you get that result, you could start checking it for things. You could check if it's an error, and you could say, oh, well, what was the error type? Was it a load error? Maybe the file came over a network, and you want to check if it was a network error. And then if you found out it was a load error, you could start to check specifics. Was it a file load error? And then that's how you get things like the file name. This really is just creating a big discriminated union for all your errors. So we're going to define this new error function, and we're going to define this error type right here. And we're going to start by defining the new error function. So I got rid of a bunch of the stuff at the bottom. And the first thing we want to describe is this input, this second parameter. The first parameter is obvious. It's just a string, so a lot of the work will be the second parameter. And as we said before, that is just a bunch of strings mapped to functions. So we've got this map down here. K is a string, and the result is a function. And I'm underlining here all the functions in pink, so you can kind of see how they relate to the explicit example above, and the keys are in green. So now that we have our input, we're going to start talking about the output. And again, we're taking these return types and bolting error information onto them. This is the information we're going to bolt on. We're going to take an error type, which is a string, and we're going to take an error subtype, which is also a string. So this is also pretty simple. We're using an interface here with type parameters because it lets us do some more complicated stuff. It lets us infer specific things about the strings. This would be useful if you didn't do that. It's more useful if we know a lot more specifics about our strings. Again, underlined in green is the main tag, and then the subtags are in pink. All right, so we're going to use just file load error, and we're going to do a specific example of what the output for that would look like before doing a generic example of output for all types. So we're going to remove some things from the screen to make space. We're going to remove this guy right here, and we're going to remove our type parameters. That just gets it down to 2 lines. And this is what the return value of that function is going to look like. It's just going to have a file name in it. And the way you would bolt on that data is you'd use a union. You'd say your error's got the main tag and the sub tag, and we just union that with whatever the return value was. We bolt it on. Now we could get any of the properties in I error, or we could get any of the properties in I file load error. But we can't paste all this code for each one of our functions. We want to generate that automatically. So we're going to get rid of those, and we're going to add our input. This is what we're actually dealing with, and a mapped type which can extract data from the input and map it to the return values we actually want. So I'm going to break down what this is doing. We're going to take our keys in the object, so these are the subtypes, and we are going to pass them in as the second parameter of I error. That's how this string is going to flow through the system. Then we're going to take the main type, and we're going to just pass that in as a type parameter. So that's how this guy's flowing through the system. The functions are going to be, we're going to use the parameters and return type keywords we discussed earlier to infer information about the values in the mapped type. So we're going to say K in key of T error input. So this is getting us our K, our keys. And then this would be a value. We're going to say for each value, which we know is a function, we want to have another function with the same parameters, but we're going to take that original return type, and then we're going to bolt on our I error information. So this is kind of a generic way to, en masse, bolt on all of that error information to all of the types that you'd find in one of these objects up here. So that's how we're going to get all the inputs and outputs of our new error function. The new error function is then going to look like this. He's just going to take the type, so the main type, this load error, and then the input, which is going to be this big object we just discussed, and he's just going to have those as parameters, and the output type as his return value. So that's it for the new error function. I'm actually not going to go into the implementation details. If you're curious, you can check out the GitHub repository. Really, it just iterates through the keys in this object and then attaches that error information for each one. It kind of nests the functions inside of another function that adds that information. All right, and then once more, this is an example of how those types are flowing through the system. Everything underlined in green is the main type, and then everything underlined in pink comes from the object. It's either the subtype or the function. All right, we've got one last thing to make, which is this guy. And if you remember from the beginning, this is going to take all of the return values we just described. So file name with the error information bolted on, or object size with the error information bolted on. And this is just going to create a big union of all those types so that you have an easy way to refer to them without kind of like pasting all that code below. All right, so this is what we had. We're going to remove some stuff, again, to get it down to 2 lines. And then this is what that error function is going to look like. And I'll walk through this one as well. So we have our output, the output we described before, and we know he's going to have a string as his main tag and some sort of object. We don't quite know what yet. This is where infer comes in. We're going to infer the type that gets passed in, and we're going to infer the input, which would have all these functions in it. And then we're going to use this values type, which takes a map and creates a union of all of the values in that map. So if you had like 1 maps to hello and 2 maps to world, the result would be hello or world. That's how this values type works. So we're going to use that on a map. We're going to say for each key in our input, for each of these strings, file load error or low memory error, we're going to take its return type and we're going to bolt on that error information. This is exactly the same thing that we did before. The only difference now is when we use values on it, it's going to kind of discard all this key information and just create a union of all the results. And again, the results are the things that are the actual errors. They're the return information with error data bolted on. All right. So I'm going to skip these slides. I just described that stuff. This is just one final look at all the stuff we made. Before I go on, I do want to get any questions about this, because I know this is a lot of code to go through really fast. It's especially complicated code with all the types around anything. So if anybody had any questions right now, let me know if they want me to clear them up.
One slide before this, the extents, you do the t extents, one below.
This guy?
Yeah, there's a question mark at the end.
Yes.
Shouldn't there be like a dot dot? But,
the colon's at the very bottom, which is now hidden underneath the Google slide.
Oh, sorry.
Yeah,
your laptop was
right. That thing is probably up. I knew that thing ruined my presentation, and I was really frustrated because I don't know how to not get it to show up. Yeah, so I'll kind of show you how we use this error type now. I do have a demo where we actually use it. So just to prove that it is the actual error type, here's the index.ts file. So here's the error type and the error subtype. Most of these are exactly the same as what you saw. There is some stuff added, like this was number or symbol or string. It's a little bit fancier. I didn't want to have all that in the PowerPoint. There's also like this special check function, which magically gets added to everything. So you can kind of automatically check these errors. And a kind of neat thing, if you like had one of these in your own code base, you could kind of bolt on information as needed. So I'm bolting on like just an error type and an error subtype, but maybe you want to do a call stack. Maybe every time the error function gets called, you want it to log to a specific file or database or network location. So it's kind of nice to centralize all the errors anyways, just because it lets you do a bunch of other stuff in bulk without having to change errors across like 70 different files. And in this example, what we're going to do is I've got some 3D models. 3D models use a lot of files. So I actually was having file load errors. I'm using 3.js, and they've got like really, I hate to say anything bad about 3.js because it is a phenomenal library, but they do have really bad error support. And I was getting all these problems loading files, and I was like, what? Like, network, like 404, what does that mean for like a graphics library? You can see at the bottom. It's like, I want to know if my like material was corrupt or my like model had some like bad vertex or something. So I'm going to run this example and kind of show you how it works. The code itself is actually pretty simple. Like, we're just going to call this load object function that I wrote, and then load object can return a file. This loaded is going to actually have your like 3D model data in it, or it's going to be one of those errors. And you can kind of see in my mouse over, it's either going to be a material load error or an object load error. That's what those two words are. And I just call this error.check function, and it's like, oh, if there was an error, we're going to alert. So here's an example of a 3D model. I'm going to refresh just so it fills the screen. So this one obviously didn't have a problem loading. But if I go to this frog model, I get this error at the top. It says load object, error loading asset slash object slash frog dot material. And if I go to frog dot material, we will see that frog dot material doesn't exist. Oh, but there's frog copy dot material. Surely this is misnamed. So now if I go in here and I rename this file and webpack everything again,
so you're having it dynamically load these files in?
I'm not quite sure what you mean by that. Can you describe what you mean by dynamic load?
Like is it passing the URL to the file, to the code, and then it's importing that?
So what I'm doing, these actually are getting all like webpacked in. They're actually just getting copied though, so it could theoretically like exist on a location on my disk. I'm not doing that though, because I had like wild dreams of like publishing it to the internet and like coming here and being like, and you could try it on your phone, but I didn't end up doing that. So it could be from anywhere if that's what you're asking.
Yeah, I was wondering if it's like doing dynamic imports and code splitting.
Oh, I mean, it could. I'm just webpacking it because it was the easiest way to get it on the web.
That's fair.
I'm using dev settings for my webpack anyways, so like, I didn't really care about like how big it was or anything. I actually had a bunch of 3D models laying around that I hadn't used for anything, and I was like, well, I could use these in my TypeScript talk. So yeah, you can see now the frog loaded now that I did that, now that I added the material. And likewise, if there were an issue with the object file, you'd get an object error and you could alert on that or do whatever you want. Prior to that, I would get like a 404 error or something crazy that had nothing to do with 3D models at all. And I was like really running into problems trying to load those. So that's it for the talk. I've got a few more 3D models. I've got this kind of like cool looking cube thing. And then I'll just show you one more. I got this crazy scribble looking thing. Yeah. But,
Can you see the Dark Knight one?
oh, you want to see the Dark Knight one? So it's not Batman, unfortunately, but I'll show you what it looks like. So I'll just show you all of them if you're curious. So this is the Dark Knight. He's got wings. He's got. I've got a Light Knight too. Yeah. So he also has wings and he has a halo. The lighting settings are set up for the ship, so these guys aren't lit as well. But yeah, you can kind of get the picture. And then I've got a girl as well. Yep. And I think that's it for those are the only ones I exported for this presentation at least. Does anybody have any questions? All right. Looks like we got one question.
Just curious, like, do you feel when TypeScript in the typing, it's pretty thorough, kind of complicated? I imagine it probably takes someone with pretty adept skill to maintain it if you were to pass it to someone else. Do you feel at some point it gets too complex that maybe keep it more simple?
Yeah, I think it really depends on where your problems are as an organization. So I heard this quote once, which I think is really great, which is that architecture is that which contains entropy. So it's like, if for some reason you had a bunch of entropy around your error libraries, like maybe you're a large organization with a bunch of different dev teams and they're all doing errors differently. And then it's like, oh, well now we want to log them to a central location, but like we got to go tell the graphics team to change their error logging stuff, and we got to get the UI team to go do theirs, and the networking team has to do it, because we didn't have this centralized thing. That's like having a lot of entropy, because now like one small push in the system is creating like all these huge network effects throughout the organization. So that's where you'd be like, okay, we should have just, or in the future, we're going to make the error library more complicated, because we believe that the more complicated error library is going to trap all the entropy of those network effects. So it's kind of like you created this high entropy location where you know if you touch on it, you know, you kind of have a known amount of work rather than all the network effects. And that's kind of like how I would think about it. That's my 2 cents on it. Any other questions? All right, hope you guys enjoyed it.